Hey guys, so here are examples 3 to 5 on graphing exponential functions. First, we would like to identify the parent, and by how we know what the parent is based on the base, okay? So for this question, your base, right here, let's write right here. Your base is 3, so that means y equals 3 to the x is the parent function. So once you have identified the parent function, you can use the same 5 input from our other parent functions. Now you just have to slowly work out your algebra. So the first x is -2. What we want to do is 3 raised to the power of -2, which is going to be 1 over 3 squared, which is going to be 1/9. Then 3 to the -1 is going to be 1/3. 3 to the 0, anything to the 0 is always 1. 3 to the 1 is going to be 3. 3 squared is going to be 9. Those are the inputs and outputs for your parent. Next, you want to identify your A, H, and K. Your A is 1 because technically this graph can be rewritten as 1 times 3 to the x minus 4 minus 1. Remember, let's go back up really quickly. Remember, the format of your equation is like this. Can you see this right here? It's always A times B to the power, okay? And then K is in the end. So in front of that base, if you don't see any number, that's normally because it is 1. Your H value, because X is minusing 4, H is positive 4, and your K value is -1. Since we don't have any A value, we just have the transformation of right 4 units, so we add 4, and down 1 unit, so we subtract 1. So let's use all of the inputs and transform the input, all of the outputs and transform the outputs. -2 plus 4 is 2, -1 plus 4 is 3, 0 plus 4 is 4, 1 plus 4 is 5, 2 plus 4 is 6, 1/9 minus 1 is -8/9, 1/3 minus 1 is -2/3, 1 minus 1 is 0, 3 minus 1 is 2, 9 minus 1 is 8. We do have enough to plot. Now before we plot, remember the parent function always have, all parent function and exponential will have a horizontal asymptote at y equals to 0. Because of the K value, we are now moving it down 1 unit, so you do have a horizontal asymptote at y equals to -1. And make sure we start with the horizontal asymptote because all of your points should be above that or below that. If you have points, some above, some below, that means you did something wrong. So first we're going to plot 2, -8/9, whoops. 3, -2/3, getting closer and closer to that 0. 4 is now 0. 5 is 2. 6 is 8, so I'm going to shoot all the way up to here. Remember, this should be a smooth, don't touch the asymptote, make sure we have arrows on the 2 ends, okay? If you miss your dots, sometimes I do miss my dots, and just make it really, really big. All right, let's fill out our chart. Your H and K value, that's 4, -1. X-intercept, when y goes to 0, so that's immediately 4, 0. Y-intercept looks like we do have 1 right there. I can't really eyeball that, so let's work that out really quickly. X equals to 0, so y equals 3 to the 0 minus 4, which is -4 minus 1, which is 1 over 3 to the positive 4 minus 1. 3 to the 4th, this is going to be 81, so 1 over 81 minus 1, which is going to be -80 divided by 81. So your y-intercept, write it as an ordered pair. If you don't, you will lose points, so make sure it's an ordered pair. Okay? Your domain is always all reals. Your range is going to be y is bigger than 0, or you can write it as 0, oh, not 0, we move it down 1, my bad. Y is bigger than -1, so you can write it as an interval of -1 to infinity. It is an increasing interval, and it's increasing all the time over the domain. If everything is reserved for increasing, there should be no decreasing. The rate of change will vary. It is definitely a 1-to-1. We talk about having a horizontal asymptote y equals to -1. We do not have any vertical asymptote because it's increasing, it is growth. Okay? So that's example 3 with the base of 3. Now let's go on to the next. Oh, I forgot the transformation. You have 2. Right 4 units and down 1 unit. Okay, let's go on to example 4. Example 4 is very similar, except now we have a base of 1/3. You have an a value of a -2, the h value of -1, and a k value of -6. So immediately we can fill this out. -1, -6. Okay. Now, because your base is 1/3, you're going to have y equals 1/3 to the x. That's your parent function. You will use the same 5 inputs and work that out cautiously. 1/3 to the power of -2, and we talked about flipping the inside fraction. So that's the same thing as 3 squared, which is 9. 1/3 to the -1, which is the same thing as flipping the inside fraction and making your exponent positive. 1/3 to the 0, that's always going to be 1. 1/3 to the 1 is 1/3. 1/3 to the second power, negative second power. Sorry, your x is not positive. 1/3 to the second power is going to be 1/9, okay? So those are your inputs and outputs. Let's use your a, h, and k and transform. X is going to be a -1. The a value is -2, so we multiply that to -2, y, and then subtract 6. I'm going to do the transformation first because I almost forgot it from earlier. So first, the -2, that will give you 2 transformations. The negative is a reflection, reflect over x-axis. The 2 is a vertical stretch factor of 2. Then you have a -1 for h, so left 1 unit. Then you have a -6 for y, and then for k, so that's going to be down 6 units. Okay. Now, because we do have a k value of a -6, that's the next thing I want to do is go and graph my horizontal asymptote at y equals to -6. Okay. Now, always start with your horizontal asymptote. Like I said earlier, all of your dots should be either above it or below it. If you have half of it above, half of it below, that means something is wrong. Let's use the parent table and then transform. -2 minus 1 is going to be -3. -1 minus 1 is going to be -2. 0 minus 1 is -1. 1 minus 1 is 0. 2 minus 1 is 1. 9 times -2 is -18, minus 6 is -24. 3 times -2 is -6, minus 6 is -12. 1 times -2 is -2, minus 6 is -8. 1/3 times -2 is -2/3 minus 6, which is -6 2/3. 1/9 times -2 is -2/9 minus 6, which is going to be -6 2/9. Okay, so let's plot. -3 is -24. I do not have -24 tick marks, so I'm just going to go all the way down here, and I'm approximating that as a negative 24. Negative 2, negative 12, I can make 2 tick marks, no big deal there. Negative 1 and negative 8, yep, totally plot that. 0 is negative 6 and 2/3, so it's right here somewhere. And 1 is negative 6 and 2/9, so it's closer and closer to your asymptote. As you can see, all of your dots are either above or below your asymptote. If you miss your dots like I always do, you can make it fatter, and don't forget the arrows on the two ends. So let's look at x-intercepts. X-intercept is when y equals to 0. Well, as you can see, you will never, ever, ever touch the x-intercept because you can't go above that asymptote. So there will be NA. Y-intercept is when x equals to 0. We already have it on the table, so we're going to write 0, comma, negative 6 and 2/3. If it's not on your table, then you have to work that out manually. The domain for all exponential will always be all real. The range, you can write it y is less than negative 6, or you can write negative infinity to negative 6. It is an increasing interval still, and it's increasing all over the domain. That means there's nothing left for decreasing. The rate of change will vary. It is definitely a 1-to-1. You do have a horizontal asymptote of negative 6. You do not have any vertical asymptote, and it is increasing, so this is a growth. All right, guys, we have one last example in graphing exponential. So let me go up really quickly. And is it frozen on me again? No, where did that go? Okay, here we go. Last example, y equals 2 times 0.8 to the power of x plus 3 plus 5. Okay, so first, let's talk about the base. The base is 0.8, and 0.8 is the same thing as saying 4 divided by 5. Okay, you can use decimal or you can use fractions. I like to use fractions. For me, I work with fractions a lot quicker than decimals. So that's my parent. I will now have my parent input. My 5 inputs will be exactly the same. Since I'm on this, I might as well write out my A, H, and K. A is positive 2, H is negative 3, and K will be positive 5. So let's work out my parent function. Okay, so 4/5 to the power of negative 2, that's the same thing as saying 5 over 4 to a positive 2, which is 25 over 16, so slightly more than 1. 4/5 to the power of negative 1, you're just going to flip the inside, so this will be 5 over 4. 4/5 to the 0 is always 1. 4/5 to the 1 is 4/5. 4/5 squared is 16 over 25. Now we have a k value at a positive 5, so I will start with the asymptote. See, I don't even need to make my table to even decide where the asymptote should be. The asymptote should be y equals to 5 because we're moving up 5 units. The parent function always have an asymptote at y equals to 0. You have an a value of 2, so that's 2 times y. An h value of negative 3, so that's going to be x minus 3. And a k value of 5, so that's going to be adding 5 to the end here on the y. Negative 2 minus 3 is going to be a negative 5. Negative 1 minus 3 is going to be negative 4. Negative 3. 1 minus 3 is negative 2, and negative 1. So you got 25 over 16 times 2, okay? That's going to be 50 over 16. So 50 over 16 plus 5. Now, from here, you can think of it as this way. 50 over 16 is going to give you, obviously 50 is more than 16. The question is how much more, okay? So 3 times 16 is going to be 48. Okay, I want you to think about that. 3 times 16 is going to be 48. So that means you have 3, and that means you have 2 left over. The remainder is 2. So that's 2 over 16 plus 5. This is teaching you how to kind of do fractions quickly. Well, 3 plus 5 is going to be 8, and 8, that's 8 and 2 16. Well, 2 16s can be reduced down to 1/8. So this is really 8 and 1/8, okay? Let me move these x's down a little bit. So next is -4. 5/4 is the same thing as saying 1 and 1/4, okay? 5/4 times 2, you can reduce that. So 5/4 times 2 plus 5. Let's reduce that really quickly. So that will give me a 2 here and a 1 here. So that's 5/2, which is 2.5. 2.5 plus 5, that's 7.5. So 7.5. Next is -3 on the x. 1 times 2 is 2. 2 plus 5 is 7. Next, I have a 1 minus 3 is going to be -2. Now, 4/5 times 2, that's going to be 8/5. Okay, so that's 8/5 plus 5. Well, 8/5 is going to be 1 3/5 plus 5. So that's going to be 6 3/5. Last one. Okay, x was -1. So 16/25 times 2, that's 32/25. 32/25 plus 2. 32/25, think of it as 1, right? And then 32 is 7 remaining. So that's 1 7/25 plus 5. So that's going to give us 6 7/25. So those are all of your inputs and outputs. All right, let's plot. -5, we need to go to 8 1/8. So approximate that. -5, 8 1/8, somewhere up there. -4, 7.5. -3 is exactly 7. -2, 6 3/5. And -1 is 6 7/25. Have all of the dots, so let's plot the dots. Make sure we have arrows on the ends. I missed all of the dots. I'm just going to make them much, much bigger. There you go. All right, let's fill out our chart. We have h is going to be -3, 5. X-intercept, it will never ever touch the x-intercept because it can't go below the asymptote. Y-intercept looks like you will have some, so let's work that out manually, okay? Y-intercept is when x equals to 0. Y-int, x equals to 0. So y equals 2 times 0.8, I'm going to use fractions. X is 0, so 0 plus 3 is 3, and then 5. So y equals 2 times, you got 4 to the third, so that's the same thing as saying 4 times 4 times 4. Then you got 5 to the third, so that's the same thing as 5 times 5 times 5. So that will give us 64/125. 64 divided by 125, and then you want to multiply with a 2 in the front. You want to write that as the simplest fraction, so that will give us 128 all over 125 plus 5. Again, you can find a common denominator and add them all up together. That will give us a fractions of 753/125. Or from here, you can go, okay, well, 128 divided by 125 is 1 3/5. I mean, 1 3/125, because your remainder is 3. 125 plus 5, and that should give us 6 3/125. So that should be our y-intercept. And don't forget, y-intercept is a point. X-intercept is a point, so always write it as a point. So 0, 6 3/125. The domain is always all real. I will write it as an interval notation this time. Y is bigger than 5, or you can say 5 all the way to infinity. It is not increasing, it is decreasing. So it's decreasing over the entire domain. The rate of change, we are going to say it varies. it is definitely 1-to-1. You will always have a horizontal asymptote on exponential. You do not have vertical, and this is decreasing, so it is decay. Now, I want to compare these two before. Oh, transformation. Transformation is a vertical stretch factor of 2 and left 3 units, then up 5 units. Now, before I call it a day, I do want to compare these last two examples with you guys. Okay, remember we talked about if A is in between 0 and 1, then that should be a decay. But on number 4, it contradicts what we talked about. And the reason it contradicts that theory is because technically on number 4, the base is 1/3. So technically it should have been a decay. But there's a trick. You have a reflection, okay, over the x-axis. So due to the reflection over the x-axis, if we didn't have that, then the graph would have been like this, okay? Then if the graph would have been like that, then that would have been a decay. So anytime you have a base in between 0 and 1 and you have a reflection, then it is now a growth, okay? So just want to keep that in mind. Now, number 5, we have a base of 0.8, which is in between 0 and 1, and we have no reflection, so that's why that maintains as a decay question. And this is the end of graphing exponential.